Okay, hello Sam and hello Jen. This one pertains to both of you because it's a spectral graph that both of you will be using, I would hope. So Sam, what we talked about today, as I see it, is a sliding bar like this. Okay, and this slider is the number of carbons. Okay, so when we do that, we're going to slide from 10 to 100 to 1,000 to 10,000. So that's what we have here. Now, if we're going to do that, I'll show you how in an Excel sheet. But now what else I want to do is introduce a second slider here that we talked about, which is the number of protons. Here's if you only add one proton. Here's, for example, if you add 2 or 3 protons. And then maybe here's 7, 8, 9, and then 20, 20, 30, things like that. So that's how that works. Now, how will you know where, for example, this one is, which is, again, this was number of carbon, and this was the same thing, but this is number of protons. Okay, so how the heck are you going to find that? Well, they're all here in this little Excel file. So it's coded thusly: carbon number here, proton number here. So this is carbon 10, 1 proton. And that's all we're going to show for the students because that's all you'll ever see in reality. So I decided to confine this matrix to reality. But for carbon 100, we'll see carbon 100 with 1 proton, 2 protons, 3 protons, and I've gone to the trouble here of modeling a composite spectrum. That's what an actual peptide looks like. This has got a +3, a +2, and a +1. Now I'm going to do composite spectra for the proteins, but this is quite time consuming. This is all I could get done today, but I'll get them and they'll feed in. And where they're going to feed in is down here. Final is composite. So this will be like, here's all these different possibilities where the protein could be, but if you add them all together, they make this gorgeous little composite. So I hope this makes sense. In review, we have our carbons here, we have our protons here in this nice little sliding graph. We don't populate the whole matrix because it's not reasonable for things with 10 carbons to have a bunch of protons, nor is it reasonable for something with 1,000 or 10,000 carbons to have 3 protons. They just won't. Turns out it is reasonable for them to have 1 proton because there's a kind of mass spec that does that. Okay, so look, I hope that's helpful, and I'm sending you this PowerPoint right now by email, and I'm putting it into the assets of Module 2.